let us now discuss about Compton scattering. Before knowing about the Compton scattering, let us first explain that what is Compton effect. Compton was the name of a scientist. So, definition of Compton effect is when high frequency X-rays is scattered from a graphite block, then instead of radiations of the frequency of incident wave, some new frequencies or wavelength are also found. This phenomenon is called Compton effect. Now, how this Compton effect was explained? The answer is, the effect was explained by quantum theory of radiation, according to which the radiations consist of quanta or photons, each having energy h nu. These photons move with velocity of light and obey all the laws of conservation of energy and momentum when they strike with the electrons of the scatterer. The phenomenon of scattering is due to collision between incident photons and the electrons of the scatterer. That is, when a photon of energy h nu collide with electrons of a scatterer, it gains some energy from photon, and the incident photon becomes a photon of low frequency and high wavelength after scattering. Right? So, this what I said just now, this can be explained by this figure, and this is the theory of Compton effect. Please see this figure, and it is the theory. If the question comes that what is the theory of Compton scattering, we have to start from here. So, we can say that during the collision, photon gives a photon of energy during the collision. This is the incident photon, and this represents the electron, one of the electrons of the scatterer. So, during this collision, photon gives a fraction of energy to this free electron, and the free electron gains some velocity. This free electron gains same velocity after collision. From figure left, after collision, phi, these angles are after collision. What is phi? Phi is angle of a scattered photon, angle of a scattered photon with the direction of incident wave. And theta is angle of recoil electron, with the direction of incident photon. Here this dot represent the one of the electrons of the scatterer, and this dot represent the required electron. This wavy nature represent the scattered photon, and this represent the incident photon. So let us see what happens before collision. This is the conditions, physical things before collision. The energy of incident photon, the energy of incident photon equal to h nu, right? The energy of the electron, the energy of the electron equal to m naught c square, where what is m naught? M naught is rest mass of the electron, because this electron of the scatterer is considered at rest before collision, so it is called rest mass of the electron, where the momentum of the incident photon, the momentum of incident photon equal to h nu by c. This is the formula for the momentum of incident photon. And the momentum of the electron, the momentum of the electron, all this data is for before collision, equal to 0. Why? Because electron is considered at rest before collision. So when it is rest, its momentum is 0. Now the picture after collision. What are these quantities after collision? After collision, the energy of a scattered photon, now it becomes incident photon to a scattered photon, equal to h nu dash, where nu dash is less than nu. The energy of the electron, because the electron will be emitted from the scatterer, so the energy of the required electron, equal to mc square, where here m is called mass of moving required electron, where m is mass of the electron, required electron in motion, and the momentum of a scattered photon, the momentum of a scattered photon equal to h nu dash upon c, where c is velocity, of course the c is velocity of light, and the momentum of required electron, the momentum of required electron equal to mv, where v is velocity of recoil electron. Pause.
Start.
Now the energy of the system. Energy of the system. What is our system? Our system is electron plus photon. This is the system. The energy of the system before collision equal to h nu plus m naught c square, and the energy of system after collision, the energy of system after collision, it is h nu dash plus mc square. And from the principle of conservation of energy, h nu plus m naught c square equal to h nu dash plus mc square. Let this be equation number 1. And from the principle of conservation of linear momentum, note down, from the principle of conservation of linear momentum in the direction of incident photon. Again I am going to repeat that from the principle of conservation of linear momentum in the direction of incident photon, h nu by c plus 0 equal to h nu dash by c cos phi plus h nu dash by c plus mv cos theta. Let it be equation 2. Again, from the law of conservation of momentum perpendicular to the direction of incident photon, again I repeat, from the principle of conservation of momentum perpendicular to the direction of incident photon, it will be 0 plus h nu dash by 0 equal to h nu dash by c cos phi, sin phi minus mv sin theta. Let it be equation number 3. Now equation 2 gives, see the equation 2, it is clear from equation 2 that mvc cos theta equal to h nu minus h nu dash cos phi. It is equation number 4. Equation 3 gives, now I there are some mathematical simplification which is I am going to continue. That equation 3 gives MVC sin theta equal to H nu dash cos phi. Equation 5. Write all this equation carefully. Now the process is squaring equation 4 and equation 5 and then adding. What you have to do? You have to square equation 4 and equation 5 and then adding. We get, if you do these things, you will get m square v square c square equal to h square. You can also do it phi square plus h square nu dash square, h square nu square plus h square nu dash square minus 2 h square nu dash cos phi. Take common h square. What we will get? Nu square plus nu dash square minus 2 nu dash cos phi. It is equation 6. From equation 1. Now from equation 1 we get, what will we get? MC square equal to H nu minus nu dash plus M naught C square. Squaring this, we get M square C4 equal to H square nu minus nu dash square plus M naught square C4 plus 2H M naught C square nu minus nu dash nu minus nu dash h square nu minus nu dash the whole square plus m naught square c4 plus 2h m naught c square nu minus nu dash. It becomes h square nu square nu dash square minus 2 nu dash plus 2h, this one 2h m naught c square nu minus nu dash plus this one m naught square c4. Let it be equation number 7.
That
let E equal to energy of the required electron, P equal to momentum. This is momentum. This is momentum of the required electron. Now we know that E equal to mc square from the Einstein's mass energy relationship and P equal to mv. Simple classical formula. The equations 6 and 7 which I have already written becomes, equation 6 becomes this one, this is equation 8, and equation 7 becomes this one. This is equation 9. Now you have to do that subtracting equation 8 from equation 9. Here is 8, here is 9. Subtract this to this. You will get the result, this one, that is E square minus P square C square equal to this plus this, right? Subtract what I have told, that equation 8 from equation 9, we get this equation. Let it be equation number 10.
Start.
This equation has been written as equation 10. Now, according to relativistic equation between momentum and energy, we have, this is the relativistic equation, E square minus P square C square equal to M naught square C4. It is equation number 11. Now comparing equation 10 and 11, we get left hand side of 10 and 11 are equal, so right hand side will also be equal. Very simple. Therefore, M naught square C4, this one, is equal to this equation, 2h square mu dash cos phi minus 1 plus 2h mu minus mu dash M naught C square plus M naught square C4. This M naught square C4, M naught square C4, cut. So, equation becomes, bring this here, it becomes this, and this one to here. So 2 cancel, h cancel, nu minus nu dash, bring it here, h, go take this here to here, and minus, when minus is multiplied here, it becomes 1 minus cos phi. From this we get 1 by nu dash minus 1 by nu equal to h by M naught C square 1 minus cos phi. It is equation number 11.
Start.
From equation 12, that is this relation gives change in frequency and indicates that nu is greater than nu dash. That is, frequency of the incident photon is greater than the frequency of the scattered photon. Now, to find the relation in terms of wavelength, substitute in equation 12. I have already written equation 12. In equation 12, you have to substitute nu dash equal to C by lambda dash and nu equal to C by lambda. We have lambda dash minus lambda h by M naught C 1 minus cos phi. This is equation 13. From equation 13, it is clear that lambda dash is greater than lambda. That is, wavelength of the scattered photon is greater than the wavelength of the incident photon. And it is true that if frequency increases, wavelength decreases, and if frequency decreases, then wavelength increases. This satisfied this one and also this one. From equation 13, it is clear that change in wavelength is independent of the frequency of the incident photon. There is no terms of frequency of the incident photon. As well as the nature of the scatterer. There is no indication what type of a scatterer is. But it depends only on the angle of scattering. As observed by Compton. Compton observed this fact that change in wavelength depends only on the angle of scattering.
Start.
From equation 13, put phi equal to pi by 2, then cos phi equal to 0. then lambda dash minus lambda becomes h by m naught c. This quantity h by m naught c, put value of h here, m naught is this one, c is this one. Since it is wavelength, its unit will be meter. If you calculate it, you will get 0.02426 Armstrong unit, because you will get here into 10 to the power minus 10 meter, and 10 to the power minus 10 meter is 1 Armstrong. So the quantity h by m naught c, value of quantity h by m naught c becomes 0.02426 Armstrong, and is called Compton wavelength of the electron. This is called Compton wavelength of the electron. The scattered photon and the required electron were observed. These two are observed and verified experimentally by two another scientists, Bothe and Geiger, in 1905. The above theory from the beginning clearly shows that the protons behave like particles when they collide with electrons. And the conclusion becomes that is the electromagnetic wave is corpuscular in nature. Means electromagnetic wave behaves like a wave and also as particle, and it is the dual nature.
Dot.
Thus, we note that dual nature of electromagnetic radiation is an experimental fact. It may be observed that electromagnetic radiation having high frequency and high energy and frequency show the dual nature. What type of wave show the dual nature? Radiation having high energy and frequency, that will show dual nature. That is, they behave as wave and as well as particle. But the condition again we said that, but when they possess low energy and frequency, so that they are incapable of ejecting an electron. Because if it has low energy, then it will have the low frequency, and it cannot eject an electron from the scatterer, and it is incapable of ejecting an electron. What happens then? At that time they exhibit only wave nature. So for proving dual nature of radiation, the frequency and energy of the incident photon must be high, so that its frequency must be greater than the threshold frequency of the ejecting an electron from the scatterer. So in this way, this Compton scattering, or you can say Compton effect, is completed. The question may be asked like this: what is Compton effect? What do you mean by Compton wavelength? Prove that Compton effect exhibit or shows the experimental evidence of dual nature of electromagnetic wave. The other topic I will explain you in my next class. Now, I want to say one thing, that if you find any problem or any type of difficulty in understanding the topic during this period, then you may consult me in the college when it reopens. I will explain everything. And at this position, and what is happening you all know, you should continue your study. Don't be seated in the room in vain, but study and try to gain the knowledge. You are the students of physics honors, so you have to labor hard. Don't treat it as an holiday, because it is also necessary for the country and for yourself and also for the society, that during this period you have to stay in home. Don't go outside for any type of work if you want to be healthy and if you want to do something for yourself, for your family, and for the country as a whole. Thank you.